On average, lightning strikes occur close to 10 million times a day. And for lightning bolts, a plane flying thousands of feet in the air is a natural target. We took an exclusive look inside the Boeing Lightning Lab to see how they manage it. You may assume that when lightning strikes an object in midair, such as an airplane, the outcome should be catastrophic. However, airplanes are incredibly resilient in the face of lightning. But why is this so? Firstly, we need to understand that an airplane is not an ideal point for lightning to discharge. As explained by the Boeing Lightning Lab lead engineer, Stephen Henning.
It depends on the amount of voltage you got potential and whether or not all of it is able to bleed off into that one spot at that point.
When an airplane is in flight, it's not grounded. That means the lightning is not discharging its full potential to the ground through the plane. Instead, what happens when lightning strikes an airplane is similar to the airplane catching the lightning. The airplane, primarily being made of conductive materials like aluminum, allows the electric charge of the lightning to travel along the plane's skin and exit back into the air. This path is known as a swept stroke. The plane is like a bird flying through a waterfall, getting wet but emerging relatively unscathed on the other side. To visualize this, picture an airplane cruising smoothly at 30,000 feet. Suddenly, a bright flash envelops the plane. It's been hit by lightning. Inside, the passengers might see a bright light and hear a loud sound, but often they don't notice a thing. The plane continues its journey unperturbed. Now, the engineering of airplanes to protect against lightning strikes is not accidental. It is a product of intentional design and robust testing. The airplane skin, made of conductive material, creates what is known as a Faraday cage. This shields the interior of the plane from external electric fields and largely neutralizes the effect of the lightning strike. That being said, lightning strikes can still cause minor external damage to planes, such as burn marks or minor erosion on the surface. In rare cases, they can affect the plane's electronic systems. But these are exceptions rather than the norm. A critical piece of information shared by our expert throws light on this concept.
In this case, we're talking about the damage you'll see on the plane as it's flying and as it's going out. Damage over time is what causes this is where you start getting more issues. That's what we want to protect. We want to make sure that our safety is going to protect the plane from those cases.
Now, you might think that since planes are virtually immune to lightning, it is perfectly safe to go through storms and never try to avoid them. But let's see how pilots interact with these dramatic displays of natural power. Despite understanding the inherent safety of modern aircraft against lightning, pilots still take precautions to avoid these atmospheric phenomena. But why? Well, the answer is twofold. First, lightning strikes can affect a plane's external sensors, like pitot tubes, which measure airspeed, and this can be a problem for pilots. Also, multiple lightning hits over time can lead to maintenance issues, and therefore it's in the airline's best interest to minimize exposure. Second, the encounter with a lightning strike can be disconcerting for passengers. The flash of light, the sound of thunder, and the awareness of being in a storm can lead to unease, and pilots naturally seek to provide the smoothest, most comfortable flight possible. Boeing's lightning protection systems also account for a phenomenon known as a swept stroke, where the lightning channel sweeps across the aircraft due to the plane's forward motion. Boeing's designers ensure that this doesn't cause the lightning energy to enter the aircraft or damage any of the exterior components. The prevention of unwanted arcs is another aspect that designers have to consider.
Sharp points create fields. Fields concentrate the fields around it. Those concentrated fields create a chance to actually jump to another point.
By designing the airplane with rounded surfaces, the risk of unexpected arcing is greatly reduced. Boeing's commitment to safety doesn't stop at just testing and designing its aircraft for lightning protection. There is also constant research and development to find new materials and technologies that can further enhance this protection. As new challenges arise, Boeing is always ready to rise to the occasion. The safety and security of passengers and crew is a top priority in aircraft design, and every thunderous clap of a lightning strike is a testament to the marvels of engineering that keep us safe as we travel across the skies. As you take your next flight, you can relax, knowing that the aircraft is well prepared for any storm it may encounter.